Hey, Algebra 2! So now we're going to solve our nonlinear systems, but instead of doing them graphically, we're going to do it algebraically. That means we're going to use algebra to do it. You have done this before when you have two lines, number 1 and number 2 here. This one is set up for substitution. So we would take 5x minus 5, which equals y, and we're going to put it right there in place of that y. So we have 5x minus 5 equals 3x minus 1, and then we go ahead and solve. So we're going to subtract 3x from both sides, and we're going to add 5 to both sides, and we get 2x equals 4, divide by 2, so x equals 2. And then to find the y coordinate, we plug it into either one of the equations. They will both give you the same answer, so y equals 3 times 2 minus 1, which is 6 minus 1, so y equals 5, and there we have our point 2, 5, which is clearly the same thing we got when we did this graphically. So let's go through, and we're going to go back through the note sheet from yesterday. We're going to go back through the problems for yesterday, and we're going to do all of these algebraically. Okay, so looking at number 1, again, we're going to use substitution, and what we're going to do is we're going to take 4x minus 24, because that equals y, and if 4x minus 24 equals y, then I can take out that y, and in its place, I can put 4x minus 24, because y and 4x minus 24 hold the same value. So now I have 4x minus 24 equals x squared minus 8x plus 12. Now this is an x squared, so what we're going to try to do is get everything equal to 0, and then hopefully factor. So minus 4x plus 24 to both sides. We end up with 0 equals x squared minus 12x plus 36. We are going to go ahead and factor this. And this factors in x minus 6. X minus 6 equals 0. Set our parentheses equal to 0, so x equals 6. Which again is what we got when we did this graphically, so that's good. And now we're going to find y. So where am I going to plug in x equals 6? I can plug it into the first equation and do x squared minus 8 times x plus 12. Or an easier place would be to plug it into the second equation, where we have y equals 4 times x, which is 6, minus 24. 24 minus 24 is 0. So we got y equals 0. So again, we got the same point we did doing it graphically, which is good news. Okay, so on number 2, I'm going to go ahead and erase all this work here from yesterday, so that I have a little bit more room, and we're going to have to do a little substitution again. So what I'm going to do is subtract 2x on this problem so that we have y equals negative 2x plus 7. So what does y equal? Well, y equals negative 2x plus 7, so I can take out this y, and in its place I'm going to put negative 2x plus 7. What we need to be really careful about is that negative in front there. So we have x squared plus 2x minus my new y, which is negative 2x plus 7, equals 5. I'm going to distribute that negative, so we have x squared plus 2x minus 7 equals 5. I'm going to combine like terms. So we're going to combine our like terms here. 2x and 2x is 4x, and I'm going to subtract 5 from both sides. So we get x squared plus 4x minus 12 equals 0, which can be factored. What multiplies to be negative 12 and adds to be 4. That's going to be plus 6 minus 2. That gives me my x values as x equals negative 6. And x equals 2, which, notice, that is what we got when we did this graphically. Now to find the y values, I need to plug this in twice. So I'm going to go ahead back to my y equals negative 2x plus 7. And for x equals negative 6, I'm going to plug in negative 2 times negative 6 plus 7. So I have 12 plus 7, I get y equals 19. So I got negative 6, 19 as 1 point. And then I'm going to plug in x equals 2 into the same equation. Y equals negative 2 times 2 plus 7. And we get y equals negative 4 plus 7, which is 3. So here I got the point 2, 3. So whether I did it graphically or on the calculator, or using algebra, we end up with the same answer. Okay, so number 5. This one we know was, number 3, I'm sorry. This one we know was no solution. That means they didn't cross at all. Okay, so let's see what happens there. Alright, so again, we're going to rewrite, and I'm going to go ahead and erase what I got here. Again, we know this is no solution. And I'm going to rewrite this bottom one as y equals, I'm going to subtract x squared, subtract 2x to the right side. So that's what y equals. So that's what I'm going to put in place for y. I'm going to make sure I get that negative out front. And we have 2x squared minus 5x minus my new y, which is negative x squared minus 2x equals negative 2. I'm going to distribute that negative through, so we have 2x squared minus 5x plus x squared plus 2x equals negative 2. Combine like terms, add this 2 over, we have 3x squared minus 3x plus 2. And now the only way we can do that, you can try to factor if you'd like. I'm going to go ahead and tell you already that you can't factor. What did I mess up here? This is supposed to be a minus 3x. Okay? So this will not factor, so we're going to go ahead, and if we can't factor, we can always use the quadratic formula, which of course you have memorized, otherwise you will sing the song of x equals negative b plus or minus square root b squared minus 4ac all over 2a. There it is. Of course you know that. So we're going to go ahead and plug into the quadratic formula here. And we get a is 3, b is negative 3, and c is 2. So we get 3 plus or minus square root 9 minus 4 parentheses parentheses, which will be 3, 2 all over 2 times a, which is 6, and this is what x is going to equal. So we have 3 plus or minus square root of 9 minus 4 times 3 is 12 times 2 is 24 all over 6, which is 3 plus or minus square root negative 15 over 6. Negative 15 gives us an I plus or minus I root 15 over 6. There are 2 imaginary solutions, which is why when we looked at it graphically, we saw that there were no real solutions. Okay, so graphically it's no real solutions. Algebraically, you can actually find those imaginary, you can find those I's. So, hopefully that's enough examples to get you through the homework. Your homework is page 136, 15 through 22, 25, and 26. Make sure you have Thursday and Friday's homework all ready to go. And have a great day.